Okay, good day again, grade 11. So now we are on question 7. So question 7 says you have now a metal sphere S with a charge of 30 microcoulombs is suspended. Then you have a metal sphere T, then which is a charge of negative 90 microcoulomb on a stand is placed at a distance d from the suspended sphere. Yeah, so this is sphere S with this 30 microcoulombs. And then you have now sphere T, which is negative 90 microcoulombs. And the distance between them is d. So 7.1 says, state Coulomb's law in weights. So let's state now Coulomb's law in weights for 7.1. Okay, so the law says the Coulomb's law says the electrostatic force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Here you don't say between their centers, you say between them, not between their centers. So you must be careful there. It's different from Newton's universal gravitation. Yeah, so that was 7.1. So now let's move to 7.2. So they said now sphere S is initially held in position and experiences an electrostatic force F due to sphere T of 1080 newtons. Determine the distance d between sphere S and T. So they told us that now sphere S initially held in position and experiences the electrostatic force of 1080 Newton. So there is a force now between these two, which is 1080 Newton. So let's find now the distance d. So that's 7.2. So the formula says F is equals to K Q1 times Q2 all over R squared. Okay, so the value for K is a Coulomb's constant. The value for K is 9 times 10 to the power 9. So it's also a constant. So the value for K is 9 times 10 to the power 9. Then they said Q1 is 30 microcoulombs. So Q1 is 30 microcoulombs. So micro is times 10 to the power negative 6. Then the second one, Q2, they said Q2 is negative 90 microcoulombs. So just going to substitute 90 microcoulombs. We're not going to put the negative because of we know if this one is positive and that one is negative, this force here is going to be the force of attraction. So after we wrote the answer, we're just going to write attraction. So you don't put a negative sign there. Or sorry, we have to divide by the distance between them. So they said now we must find that distance, which is D. Then the amount of the force they told us is 1080 newtons. So that is the value for the force, 1080. So now this 1080 is over 1, so that means we have to cross multiply here. So let's do this. So we have 1080 times d square is equals to 1 times that is all of that. So we need now to find this value, 30 micro by 90 micro. So we need to find now that value that is on the right. So let's punch that on the calculator. So it's 9 times 10 to the power 9. Then we have 30 times 10 to the power negative 6. There we have 90 times 10 to the power negative 6. Now the value on the right is 24,3. So here is 24,3. On the other side we have this value. So we're going to divide now by this 1080. On the other side we divide also by this 1080. So we want to find d square. So let us divide by 1080. So we have 0,0225. 0,0225. Now we have to take the square root now from both sides. So d will be equal to the square root. So the square root of this. So we find the square root of 0,0225. Then the answer is 0,015. Okay, so the distance now between these two charges is 0,15 meters. So now let's move on to question 7.3. Now 7.3, they said now sphere S is then released. 7.3, will sphere S then swing towards or away from sphere T? Okay, so we need to check now sphere S. So sphere S is this sphere which is positive and sphere T is that one which is negative. So that means they said sphere S now, which was suspended by this rope or cable or whatever. So if this one was suspended, in other words, if now it is being released, that means that which attached it to the ceiling is being removed. So now it is like falling. So as it is falling, is it going to move towards sphere T or is it going to move away from sphere T? So if you remove now this tension between the sphere and the ceiling, because of it is positive and this one is negative, we know that they are going to attract. So that means that is going to move toward sphere T. So for the question now 7.3, will sphere S swing towards or away from sphere T? We know it's going to move towards sphere T. So the answer here is towards. So let's go to 7.4. Provide a reason for your answer to question 7.3 above. The reason we say it's going to move toward is because we know that unlike charges attract. So it's because of unlike charges attract. So that's the reason. Okay, let's move now to the last question, or not last. Oh, 7.5. 7.5. A further two spheres P and Q are given charges of 7 nanocoulomb and 5 nanocoulomb respectively. The sphere P and Q are brought into contact. So you have sphere P, which is 7 nanocoulombs, and sphere Q, which is 5 nanocoulombs. They are both positive, and then they are brought into contact. So they brought them into contact. State the law of conservation of charge. State the law of conservation of charge for 7.5. Okay, so for 7.5, we says now the net charge on an isolated system remains constant. So this is the law they want us to write. The net charge on an isolated system remains constant. So that was 7.5. That's the law of conservation of charge. So for 7.6, are electrons transferred from P to Q or from Q to P? Okay, so for this one, 7.6, in order for us to know whether electrons will move from P to Q or from Q to P, so we need to make a simple sketch. Okay, let me just make a sketch here. Imagine like you have a charge that has 10 positive particles and 3 negative. So a net of these will be plus 7 particles because of like we have 10 positives and we have 3 negatives. So if you take 3 out of 10, you're going to be left with 7, which is a net of what you had. So for this one, you have like 10 positives and like you have 5 negatives, then the net of this one will be, you will have to remain with 5 negatives. So this charge now, which is in our case, it is charge Q. So imagine this one is charge P, this one is charge Q. So the net that remain here is 7 more of the positives. Here you have 5 more of the positives. So that means that charge P is still stronger than charge Q. It has like a more positive than charge Q. So eventually the one that is strong, the one that is going to be able to pull is the one that is stronger, which is P. P will be able to move, to pull the remaining charges from Q. Not the remaining charges, but will be able to pull whatever electrons that were on Q because of the charge P is stronger than this one because of it has more of the positive charges are remaining than that of Q. So charges we say are going to move from Q to P. They will move from Q to P. Yeah, so that's the answer for 7.6. They will move from Q to P. Okay, now let's continue to 7.7. So for 7.7, they are saying now, let us calculate the final charge on each sphere for 3 marks. The final charge on each sphere. Okay, so to find now the final charge, remember they were brought into contact here. So eventually they will separate. Then we have to find now what they would become after separation. So this is the final charge that we want to see. This is before, then they get into contact, and then after contact, what will be the charge? So let's do this one. That is 7.7. So for 7.7, we say the final charge is equals to, that is, we need to first what it was initially, that is it P and Q? Yeah, I think it's P and Q. So this is initial, divide by 2. So initially charge P is 7 nanocoulombs. So this one is 7 nanocoulombs, that's -9, plus charge Q, that was 5 nanocoulombs. 5 nanocoulombs, divide all of that by 2. So finally, we're going to have now 7 nano plus 5 plus 5. Okay, let me cancel this. So we have 7 nanocoulombs plus 5 nanocoulombs. Then that we divide by 2. So now we have 6 nanocoulombs. 6 nanocoulombs. That will be Q final. In other words, after they separated, this one will be 6 nanocoulomb and that one will be 6 nanocoulombs. So they are going to be positive 6 nanocoulombs, positive 6 nanocoulombs. Because of that, as they will be sharing electrons here, they are sharing electrons, and then after they separate. As they separate, one will be 6 nanocoulomb, the other one will be 6 nanocoulomb. That's what this calculation says. So now let's go to 7.8 and see what they're asking. Calculate now the number of electrons transferred in the process. The number of electrons transferred in the process. So remember, we said now it is charge Q that is transferring electrons to charge P. So this is the one that is transferring, which is charge Q. And charge Q, initially it was 5 nanocoulombs. And then after it transferred electrons from charge to charge P, then it has 6 nanocoulombs. So we have the Q initial and the Q final for charge Q. This is charge Q. So we want to find now the number of electrons that it transferred to P. The number of electrons that it transferred to P. So this calculation says to find the number of electrons transferred, the number of electrons transferred, you need to have now the, let me call it change in Q transferred, divide by the quantization of charge. So that change in Q, I want to find now the amount of charge final, subtract the amount of charge initial. Remember, I am focusing now on charge Q because of it is the one that is transferring electrons to charge P. So in final, charge Q is 6 nanocoulombs. Initially, it was 5 nanocoulombs. Then divide that by the quantization of charge, which is 1.6 times 10 to the power negative 19. So let's find this one. So we said we have 6 nano subtract by 5 nano. So we have 1 nano, 1 nano. We have 1 nanocoulomb divided by 1.6 times 10 to the power negative 19. So we need to find this value. So we divide that by 1.6 to the power of negative 19. So this is the amount of electrons that will be transferred. That is 6, 2, 5, and 1, 2, 3, 4, 5, 6, 7 zeros. So you have like 6, 2, 5, 1, 2, 3, 4, 5, 6, 7. So this is the number of electrons that will be transferred. So you just need to find from that charge which transfers electron, in this case is charge Q. So you don't focus on charge P, you focus on charge Q, because previously we said electrons are going to move from Q to P. So you focus on this charge that is transferring charge electrons. So find the amount of final charge, subtract the amount of initial charge. Finally, it's 6 nano. Initially, it was 5 nano. Then divide by the quantization of charge. Yeah, so that's how you calculate that number of transferred electrons. So that was the end of question 7. Now we're moving to the last question, which is question 8. All right, so now this is the last question, which is question 8. So in question 8, they said we have 3 charges X, Y, and Z are placed as shown in the diagram below. So this is charge Z, which is negative 4 nano. So this charge is negative. Then we have charge X, which is 5 micro coulomb. So this one is positive. Then we have Y, which is negative 5 microcoulomb. So this one is negative. Then the distance between Z and X is 0.03 meter. The distance between X and Y is 0.04 meters. So they said 8.1. We only have 3 questions here. Calculate the magnitude of the net force on sphere X due to the presence of Y and Z. So calculate the magnitude of the net force on X. So we want F net here on X as a result of Z and Y. So let us get an idea. So we have this charge here, Z and X. There will be a force between Z and X. If you look at Z, Z is negative and X is positive. So obviously there will be a force of attraction here where Z will attract X to this direction. So this is the force of Z on X. And then if you look at Y and X, you can see Y is negative and X is positive. So there will be also a force of attraction here. So Y is going to attract X now to this direction. So there will be a force of y on x. And then the net now will be between these two forces. That will be your tail-to-tail vectors. So this will be your F net. So in order for us to find that F net, remember this is like r squared is equal to x squared plus y squared. So x squared being this one and y squared being this one. So we need now to find this force, which is f of y on x, and we find that force, which is f of z on x, and then we're going to find now the square root of the two, then that will be our F net. So that's what we have to do for this one. So that is 8.1. So we first find the force of z on x, which is equals to k qz on qx all over r squared. So we said k is 9 times 10 to the power 9, and the qz, the charge on z is 4 microcoulombs. So the first one is 4 microcoulombs. Don't put that negative, just say 4 microcoulombs. And the charge on x is this one, 5 microcoulombs. So we put here 5 microcoulombs. Then the distance between the two is 0.03. So it's already in meters, so it's 0.03 squared. So we punch that in the calculator. So we have 9 times 10 to the power 9. Then we have 4 micro. Then we have 5 micro. And then that answer we divide by 0.03 squared. Okay, so we have 200 newtons. This is the force of Z on X, that is the attraction force. Now we go and find the force of Y on X. The force of Y on X will be KQY times QX all over R squared. So we continue and say, then K is the constant, which is 9 times 10 to the power 9, and QY is 5 microcoulombs. You don't put the negative, just say 5 microcoulombs. Then X we said it's 4 or 5, also 5 microcoulombs. 5 microcoulombs. Then the distance between the two, is 0.04. So we have 0.04 squared. So we punch that to the calculator. We have 9 times 10 to the power 9. Then we have 5 times 10 to the power -6. Okay. And then the other one is 5 times 10 to the power -6 as well. Then we divide the answer by 0.04 squared. So here we have 140.625. 140.625 newtons. So that's Fy on Z. Now we go to find F net, which is a square root now of this one, 625, 140.625 squared plus the other one, which is 200 squared. So let's find this value. So we take the calculator, then we set square root of 140.625 bracket squared plus 200 bracket squared. Then we have the answer is 244,49. 244,49 newtons. Okay, so that was not difficult. So that's F net. Now they did not say you must find the angle or the direction, but sometimes they like to say find the magnitude and direction. So just for interest sake, let's just do also the direction, which is this angle. There's an angle here, so let's also find that angle. That angle will be theta, which will be a change in tan inverse over, it's y over x. So in our case, y will be this one, which is f of z, which is 200 newtons. And then this one will be that one, which is 140,625. Yeah, so it will be tan inverse of 200 divided by 140,625. So the direction of the angle of the net force at that angle will be shift and tan inverse. Then we have a fraction, we have a fraction of 200 divided by 140,625. Then we close the bracket. Then the angle would be 54,89. It will be 54,89 degrees. Yeah, in case maybe in future they ask you to find the angle, that's how you find the angle. So let's check now the last question. So second last question, 8.2. If the distance between x and y was increased, what effect would that have on the magnitude of the net force on x? Choose increase, decrease, remain the same. Now, if the distance was increased, now remember the relationship between the force and the distance is always inversely proportional, as you stated in the law above, that the electrostatic force between two charges is directly proportional to the product of the charges, but this force is inversely proportional to the square of the distance. Now they are saying if now this distance is being increased, what would be the effect on the magnitude of the net force? Obviously, it will decrease. So the answer here is it will decrease or decreases. Now, last question, 8.3, provide explanation for your answer to question 8.2. This is the explanation. The net force or the electrostatic force on the charges is inversely proportional to the square of the distance between those charges. So if you increase the distance of the charges, the force, the net force will decrease. So that's how you explain that one. Yeah, so that is the end of our test, which was 100 marks, 8 questions.
Jesus Hey, you